Let's take a look at the momentum and the center of mass frame. So I know that the total momentum is the sum of the individual momentums. And I here is not for initial. I in this case is for the I equals 1 to however many objects I have. So when I is 1, I'm talking about the first object, I is 2, and so forth. So momentum is just mass times velocity, so I'm going to sum up all the mass times velocities. Velocity is just mass times the change in position over change in time. Now this notation, if you're not in the calculus-based course, you can also treat that as delta R sub I over delta T. This is sort of calculus notation, and this is non-calculus notation. There is a difference between the two in that dt is delta t for very tiny change in time. So since mass is not changing with respect to time, I can just pull that in so that the change m times the change in r over change in t is the same as change in mr over change in t. Because m is not changing, it doesn't matter if I put it in or put it out. So going this way, I'm distributing, and going that way, I'm factoring. We end up with the change with respect to time of this m of mr. Now, if you recall that the position of the center of mass is equal to this, that's in a different video. So if I multiply both sides by the total mass here, I have the position of the center of mass times the total of mass is equal to the sum, this numerator here, of each individual mass and its position. If I let capital M be the total mass, and that's a common substitution that is used in physics. So if I let M be the total mass, then momentum is change in the total mass times position. So that right there would be the total mass. This right here, as we established up here, if I take this with the change in time, that is equal to momentum. This right here, we saw right here. So therefore, if I substitute this in for that, I get down here that the momentum is the change of this total mass times the center of mass position over dt, which is, since this is not changing with time, that's the total mass, I can factor that out, and I now have this. And this is the change in position over change in time, which is just velocity. Now this is the position for the center of mass, as indicated right there. So this is mass times the velocity of center of mass. In other words, the momentum of a system is just the total mass times the velocity of center of mass. So in a closed system, since the change in momentum over change in time is 0, in other words, momentum is conserved, momentum is constant, the center of velocity of the center of mass is constant. So the movement of the center of mass is not affected by interactions of the objects within the system. So if I take a wrench and I throw it, the center of mass, wherever that might be, is going to be traveling in the parabolic. Even though this might be spinning around, but the center of mass will be traveling in a parabola. Of course, I'm ignoring air resistance. Why would you think I wouldn't? In an open system, then the change in momentum over change in time is equal to mass times acceleration. So this is my force is equal to mass times acceleration. And so that is the external force acting on it, which would be actually the example of this right here. But think about this in terms of our perfectly elastic collision. If these two things collide in a perfectly inelastic collision, so two objects colliding perfectly inelastic collision, I have no external influences here, then the center of mass is not affected by it. The center of mass is going to have a constant velocity, as shown up here. And so that center of mass is just going to keep moving whichever way it happens to be moving. Now, if I suddenly make it a perfectly elastic collision, well, that center of mass is still going to keep doing whatever it was doing. Well, there are no external forces, so the center of mass has no influence on it. And so the zero momentum frame would be the one in which you're traveling the same velocity as the center of mass, which is why the perfectly inelastic collision solution is how fast you need to go if you're doing what I generally term as technique 3 for solving the perfectly elastic collision.